Probably good to get started now. So hi everyone, my name is Bethany Griggs, and I'm excited to be back here at OpenJS World. Actually, my first ever conference was here in Austin about 6 years ago, so it's good to be back. And today I'm here to talk to you about the fun of debugging Node.js upgrades. First, a quick bit about me. So I am a senior software engineer at Red Hat in the Node.js Runtime team, which means I get to spend a good portion of my time helping out in the Node project, helping to maintain the runtime. But the rest of my time, I get to work with teams at Red Hat that are using Node.js and sharing the expertise that we learn from working within the project itself. I am on Node.js and particularly active in the release working group. And this means I spend a lot of my time helping to prepare releases of Node. So a lot of my time helping to prepare the releases, shepherding the major releases out. In case you missed it, the big news from the Node space is that Node.js 18 was released not too long ago now, on the 19th of April. And actually, it was one of our more featureful releases. Typically, our major releases happen to be just the series of breaking changes we've built up, waiting to be shipped out. But in the case of Node 18, we actually shipped quite a few new features that a lot of folks got excited about. So, new release, shiny new features. Some of the key highlights in the Node 18 release included the Google Chrome upgrade, and it's through a V8 engine upgrade, And it's through the Google Chrome V8 upgrade that we pick up all the new JavaScript syntax and features and things like that. I believe we got some additional array methods or APIs through that upgrade. The other big news was a bunch of new globally available browser-compatible APIs. So I'm sure if you went to Ethan's talk, you heard about Fetch coming to Node. That was a very much anticipated API. It's great to have an experimental version of it available. And similarly, we got the web streams APIs, again, similar vein, and also the test runner. So as of Node 18, there's a very minimal test runner shipped with Node. It's experimental. A lot of hard work done by Colin from the TSC there. So lots of shiny new features to get your hands on. I do believe my colleague Michael will be going through some of them in more detail after this talk, so stick around. But that's the positive side of a new release. But actually, the reality is upgrading to a new Node version takes time, effort, money. Not every business out there is, deploying several times a day, like you hear many are. And in my experience in the enterprise, you actually have to wait for a window where all of your other priorities have lapsed, or you've tackled some of your key priorities and found a window in which you can take the time to upgrade. And that's why I thought I'd come here today and share some techniques I've learned while helping other teams to upgrade to new Node.js versions, particularly the major versions. And really, I'm going to approach this with increasing complexity, starting with what some may feel was the obvious steps or the high-level steps, and then maybe going a bit deeper when you hit a key issue. The first piece of good context to have is to really understand how Node.js releases work and how the commits actually appear in the history of the releases. The first thing to appreciate is Node.js aims to follow the semantic versioning standard. I'm sure many folks are familiar, but the first number is incremented with a breaking change. The second number is incremented when a feature is added in a backwards compatible manner. And the third digit is incremented for all the patches and changes that neither are breaking or add new functionality. So we try to adhere to this semantic versioning standard, but there's a bunch of caveats that come with that. First of all, who gets to decide what's a bug fix or a breaking change? What we found over the years of working in the Node project is a lot of applications are actually relying on buggy behavior. So even if it is a bug, we may need to consider that a breaking change. So it's definitely a discussion, and semantic versioning is a standard we try to adhere to and guide our decisions, but sometimes we may need to elevate a bug fix to a breaking change because it's going to break just so many applications, and we want to be able to give our consumers and users the time to upgrade when that breakage comes along. The other exception is for security releases and security fixes. So we have a policy in the Node project that if there's a critical vulnerability or a security issue that requires a breaking change to fix it, we can land that in an existing release line. So that when the Node project maintains multiple release lines of Node, we actually do land breaking security changes in those. We are aware this can be disruptive, so we often do try to help you out and supply maybe a revert flag so you can revert that change and work around the behavior until you have time to patch. And there's also unexpected side effects. So authors, PR authors, commit authors do their best effort of trying to determine the impact of the change they're contributing to the project. But sometimes there's unexpected side effects that no one anticipated, and it's just exposed a part of, Node we didn't think would be affected by that particular change. So all a bunch of caveats of why you may hit breaking changes in minor and patch releases too. But we try to avoid it, we do our best effort. Above that, Node aims to have a predictable release schedule, 2 major releases per year. This is, again, with consumers in mind. We want to have a predictable schedule so that they can plan their upgrades accordingly. And we also have this concept of current and long-term support. So even-numbered release lines are granted long-term support status, odd-numbered ones are not. This is why in the chart you can see Node 19 is only supported for a short window. Generally, our distinction is use the current release line if you want to get your hands on the latest and greatest features. Whereas long-term support releases are more aimed at the enterprise or the production use case where you want stability and guarantee over time. And that's why you see a lot of enterprises saying they stick to the long-term support release lines only, they never adopt the odd-numbered versions. But that means for most companies, when it does come to upgrading, and you are sticking to just the LTS lines, you actually have to make a double jump when you go to upgrade. This means you're picking up the breaking changes from 2 versions, so you need to make a much larger jump. And this can make it much harder to isolate the particular change that's caused your issue. And this is all relevant because the first port of call when trying to upgrade a Node version tends to be the changelog, but you do need to know which ones you need to refer to. So when upgrading to a new major version, you want to look at the 00, so 15.00, changelog for that release. But actually, if you're upgrading from 14 to 16, you'd also need to review the changelog for 15.00 and 16.00. So you've got 2 sets of breaking changes you need to accommodate and review. And going on more, so with our changelogs, the Node project does aim to identify commits so you can get an idea of what area of runtime they touch. We have this concept of subsystems. So if you see our commit messages or entries in the changelog, you'll be able to see we list debts, HTTP. This is so you can filter down. If you're hitting an issue and you know it might be HTTP related, you'll be able to review the changelog and filter the changelog of the potential candidates. So this is great when you have an issue that has known impact, known errors, and known workarounds. And one I think we did really well was the OpenSSL 3.0 upgrade, which came in Node.js 17. We knew this would be a breaking change and have ecosystem impact. So what we did is we called it out in notable changes. We were able to describe what the impact would be. We were even able to specify you may hit this error message. And also we went a step further and provided a flag where you could revert and work around some of the old bit. Work around and keep some of the old behavior. So that's great. But it's really not always this smooth. And this is where I want to talk through one of my recent experiences at Red Hat. And so at the start of the year, I was tasked with helping a team update their JavaScript client for their project up to Node 16. And this team actually was a predominantly Java team, so they didn't necessarily have any Node.js expertise within their group. They just had this JavaScript client to maintain. And what the product was, it's called Infinispan. It was like an open source data grid. Think kind of like a Redis equivalent. And they needed to support Node 16. So they reached out to our team to ask for some help. This is where I'd like to share some of the techniques I used with increasing complexity to try and figure out what was happening. So step 1 was some very, very typical debugging techniques. So run it with Node 14, it passes, 16, it hangs, Node 15, it hangs. At the same time, I was also able to isolate the very specific test that was failing. So again, you want to do that so you don't have to rerun the whole test suite each time. So As first steps, pretty reasonable. I found the exact test that was failing, and I narrowed it down to the window between node 14 and 15. And just to give some background on what this test was doing, because it's relevant slightly later in the talk, is it sets up two InfiniSpan clients, A and B. It expects to be able to persist and reads data to both. It then destroys one of the clients, attempts to persist data to the client that it destroyed. But what should happen is when you try and write data, it should fall back to the client A that's still available. So it's essentially testing the fallback behavior of this client. So again, once I found the test case, I did some very, I'm sure, familiar techniques to what people use, very, very intense. It was good. From this point, I was able to at least get to the point of saying this is roughly where the test is hanging. So it was a great step forward. Then I figured I need to try something a bit more intentional to debug this. So I pulled up the Chrome inspector and run the test node inspect with the Chrome debugger. Tried to step through it and see what was going on with my breakpoints. And what I found is I was just stepping through the ticks in the event loop. I was just waiting for something to happen that never happened. So actually going through these steps, it wasn't obvious to me what was actually going wrong, because all I was doing was waiting for something to happen that never happened. So I had to take a step back and really try and think about how can I approach this next, like what are my next steps? And this is where I resorted to git bisect. If you're not familiar with git bisect, it's a command that uses a binary search algorithm to find which commit in your history introduced a problem or a bug. So in this case, what I had to do to use it was check out the main branch of Node, identify a good and a bad commit. I knew it was within this window. I set a very wide window at first, and then start the git bisect process. And at each step, I had to build the Node runtime and run the tests. And if anyone would like to do this themselves to help with their own debugging of Node, you'd need to be set up to build Node in the first place. And a good place to refer to, if you're doing that for the first time, is the building markdown file in the Node.js Node repository. So I set out to use git bisect. It can take a long time to run, but I did set out to create a little demo of my flow, if I can navigate the window to bring it up. Bear with me. It's not so easy. And I say demo, I pre-recorded it. So, oh, yep. So to start git bisect, you call git bisect start. That just initializes the bisect. You supply it the good commit. In this case, it was the node 15 release commit. And you supply bad commit. I supplied a very early bad commit, the node 13 bad commit, I believe. And you can see I had like 1,700 odd revisions to test. And what you can do at each step is run your tests and run your build. What I've done is I've just like simulated this, because I'm sure you don't want to watch me build Node like 20 times over in this talk. But yeah, I build Node with the make J32 and then run the test. And then when the test hangs, I just apply good, bad, as I can start to find a problematic commit. I believe it's still going. And what you can do is automate this into a script. So you could write a simple like shell script to run these commands for you and supply it to git bisect with git bisect run. And then you can kind of just run it, walk away from your laptop, and come back, and it works. So gradually getting there. It can take some time. I think we're on last one. Yes, so I managed to find a commit. This is great. I found a problem. And now I will go back to, sorry, I'm trying to find my mouse. Go back to here. This is really difficult from where I am. Okay, right, so I found a problematic commit. Great. So what you could do here is look at the file diff, look at the changes, try and figure out what's going wrong. But for most folks, actually, particularly this team, if this team was doing that, they don't have, the low-level context of the Node runtime. like digging into the Node source code when you're just trying to debug an upgrade issue isn't easy for everyone. So I stepped back and thought again, because I reviewed the code and I couldn't actually figure out why it was breaking and the way it was breaking. So I thought I'd try another technique that some folks may or may not be aware of, which is using the node debug environment variable. So what this does is it enables a low-level debug logs from the node runtime, and you just supply node debug and the subsystem. And these are the subsystems I mentioned earlier, roughly from the changelog. They roughly equate to each other. So you can specify HTTP, net, stream, FS, and you get that low-level log data from the runtime itself. You can supply, like, enable all with asterisk, but that will have timer output, and it just pollutes it. So it's good that I'd already figured out it was a net or stream-related issue, so I knew which subsystems to supply. And then I was able to compare the node debug output between the two versions, so node 14 and node 16. And I used like a git diff or a rich diff to do this. But what I did find is the node 14 was emitting an error that wasn't being emitted in node 16. So I'd at least managed to realize like an error should have been emitted, but no longer is. So I was a step closer, and as you can see, the command to run it, I just set the environment variable and then the path to my file I want to run. So at this point, I spent a few days on this, and I was like, I still don't know why. I'm a few steps further, but I can't put my finger on it. So at this point, I did ask some experts for help. So I know it was streams related, it was a streams change, I knew the authors and the reviewers of the PR. So I reached out to them to ask for some help and to say, hey, what do you think I should do? And this was the first bit of advice I got, which I was at that point. So pretty good. But actually, they did come up with a really, really valuable piece of advice, which was to create a minimal Node.js core reproduce. So at this point, I'd stepped through the test so many times. I was so familiar with what I was doing. I'd logged the low-level output. It was only at this point I was able to do this because I actually understood what was going on. And what I could understand is that what the test was simulating was the creation of a server, the creation of a socket. It would then destroy the server and then try to write to that socket. And the error should have been emitted. And it was that error being emitted that was triggering the fallback behavior of the client, so everything would start falling back and the second client would pick up the read. But the error wasn't being emitted in node 16. So actually, I was able to, this is a shortened version of the full minimal reproduce I had. And you can see it was actually the socket right at the bottom there, which happens after the socket's been destroyed, did not emit an error in node 16. In node 14 it did, in node 16 it didn't. I was like, this is strange. So I referred back to the docs. I now had a minimal reproduce I could speak to the experts with. And what I realized is all I needed to do was actually register a callback so the error could be surfaced and thrown. So it was interesting, managed to figure out eventually, and I could then go back and apply this change to the high-level code in the JavaScript client of my team. So that's a whole bunch of techniques that I used. Like the first was like to isolate the test failure and isolate the specific version that introduced the change. For isolating the version that introduced a change, I tend to actually do that manually just with like NVM. So just NVM the versions myself to see when it was introduced. Then review the changelog for that version, guided by the subsystem. So using, looking at the error, trying to guess roughly, is it related to streams? Is it related to HTTP? And reviewing that filtered subset. Then tried, all the traditional debugging techniques like console logs, the Chrome inspector. In this case, that didn't solve it for me. I did resort to a git bisect of the node runtime. And you may say, why didn't you go to that straight away? First, that can take a lot of time to run. It's quite, costly to do that. But also, if I hadn't actually really understood, step through the code, run the Chrome debugger, and gone through it, even having that commit probably wouldn't have helped because I really needed to understand what was going on to realize why that commit was impacting this client. The other thing is to enable runtime debugging with the node debug variable, and also asking the experts for help. Any place you can, GitHub repositories, node help repositories, Even on Twitter, I think I got offers for help when debugging this. So anyway, you can, reach out and ask. And actually, I give a gold medal to the suggestion of, providing a minimal Node.js core reproduce, trying to get to the point where you can reproduce the error with just Node core. Because not only does this help you really understand why you're being impacted by that particular change, but it also means the maintainers are in the best position to help you. Because if you come to them with a minimal reproduce and say, hey, I'm hitting this problem, this is my code using just Node, it's much easier for them to step in and help. And in the last couple of minutes, it's kind of like, how can you prepare for an upgrade? Like, how can you make this easier in the future? And there's really one piece of advice I tend to recommend to teams and folks, and that is to, skipped ahead, and that is to add the current version. So at the moment, Node 18 is current, but not long-term support. Even if you don't adopt current versions, try running your application or your module routinely with that version, because then you'll be able to, just gauge and keep on top of how difficult your upgrade path is going to be. And some teams like to go as far as adding the current version, so at the moment Node 18, to their matrix, their CI test matrix as early as possible, because this means you're getting that feedback of, hey, is it likely to break? And again, this is just preparing. If you're going from LTS to LTS, testing with the interim current version is valuable. And last thing I'd like to call out is, in the PKG.js org, which is an org with a bunch of contributors from the Node project and other spaces, we've created a PKG.js action. And what this does is it automatically creates a matrix for you to test against the LTS versions of Node. So it figures out what are the LTS versions, and then will automatically update your matrix. So no time would you have to go and add a PR to add a new version. It just does it automatically and runs the suites. And actually, there is a setting in there where it will do, like I recommend, which is to test against all the LTS versions and the next current version that's currently up. This was a lot of work done by Dominicus at Nearform. So I'm sure he'd really appreciate the feedback and people to try it out. So please do take a look. It's quite nifty, I think. With that, I just want to reiterate, if you are hitting a problem upgrading, please don't hesitate an issue, speak to a maintainer, just raise the problem. Because firstly, it may have been an unintentional change. We may not even be aware that you were impacted by it. The second is it may have been undocumented, or maybe we didn't document it well enough. So you raising it to us helps us to help future folks. And also, it helps us to assess the impact of similar changes in future. If we listed something as a patch that actually broke a bunch of people, we will know in future, when a similar change comes along, maybe we should be a bit more cautious, maybe it needs to be major. And the places to raise issues like that are the Node.js help or the Node.js Node GitHub repositories. And with that, I think we're at time. So I thank you all for joining, and if you want to chat about upgrade problems, I'm happy to be a listener. So, cool.